All right. Good afternoon, everybody. It's a pleasure that we have you here today. We are back in giving you the yearnings, satisfying your wants, giving you what you need in order to ace and brace up where you are at home. With respect to the promise that we've made to students nationwide, that we'll continue to solve problems and give them solutions beyond boundaries. Following the request of many of our students, both online and offline, that we extend our reach, we extend our tentacles to the post-UTME students. By the special grace of God, that exactly is what we are going to be doing today. By the special grace of God, we've had a plan, an holistic plan, with some of our team members. Kudos to Chemistry International. We'll be covering chemistry, mathematics, physics, biology, and host of all of this. But today, especially, we'll be looking at questions, we'll be solving questions. I'll be giving you an inside information with respect to post-UTME requirements of the series of higher institutions. Take a look, take for instance, University of Lagos, University of Ibadan, FUNA, University of Agriculture, Abeokuta. By the special grace of God, we'll be doing justice to this series of questions. We're starting from UNILAG, University of Lagos, by the special grace of God, today. Now, like we have promised, our syllabus, our objective today is to solve problems, post-UTME problems. And as we are solving each problems, we'll be looking at, we'll be extending our reach into the topics where the questions can be gotten from. So if I'm solving the questions, I'll be looking at the topic, I'll be extending the explanation to the several areas where questions can come from in that same topic. So by the special grace of God, we are having 10 questions from UNILAG past questions. I hope and pray that we'll be able to cover the 10 questions before the end of this presentation. Question number 1. The question says, the elements 25 has an electronic configuration ending with option A, 3D5, 4D5, 5P1, and the last option is 4S2. This question is coming from the inorganic perspective of chemistry. We are trying to look at electronic configuration. Believe you me, electronic configuration simply means arrangement of electrons for atoms in the atomic orbitals. Ladies and gentlemen, each of the atoms that we have in the periodic table, starting from hydrogen up to uninoxion, each of these elements has their electronic configuration. And believe you me, if you want to write electronic configuration for any element at all, you must know the atomic number of these elements. For instance, the element 25. This 25 is giving us nothing but information about the atomic number of the element, meaning that the element has an atomic number of 25. Electronic configuration. An element that has an atomic number of 25 should therefore have electron number of 25. Now, the requirement is to tell the electronic configuration, the ending of the electronic configuration. Ladies and gentlemen, if you want to write electronic configuration, all that matters, all that you need is what? All that you need is a series of mathematical representations. For instance, you must understand typical facts. Number 1, you write some figures, 1, 2, 3, 4. Let's give it a stop here. Ladies and gentlemen, 1, 1 is a figure that appears one time. 2 is a figure which means 2 things, 2 times. 3 is a figure that appears 3 times. 4 is a figure that appears 4 times. On our periodic table, we have 4 different blocks that our electronic configuration must cover. These blocks are the S block, the P block, the D block, and the F block. We call it SP, D, and F. SP, D, and F. Now, we arrange our blocks here. We have S, 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 P, 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 V, V, and F. S, P, D, F. Ladies and gentlemen, in order for you to understand electronic configuration, you must understand this pattern of numbering. After understanding this pattern of numbering, you must equally know that we have 4 different orbitals: S orbital, P orbital, D and F orbital. Now, each of these orbital has a maximum of electron that they can take. You know, what we are trying to do is that we want to arrange electrons in this orbital. Each of these orbital has a maximum number of electrons that they can take. For instance, S orbital can take a maximum of 2 electrons. P can take a maximum of 6 electrons. D a maximum of 10, and F a maximum of what? 14. So that is why on each one of these orbitals, S orbital, you put 2. On P orbitals, you put 6. On D orbitals, you put 10. And on F orbital, you put 14. You discover that there is a difference of 4 electrons between each orbitals. S is 2, 2 plus 4, 6. P is 6, 6 plus 4, 10. D is 10, 10 plus 4 is 14. Now we want to arrange electrons of elements that are 25 in numbers with respect to this. But before you do this, there are 3 laws that we must take note of whenever we are writing the electronic configuration. The first law is off-bow principle. The second rule guiding electronic configuration is Pauli's exclusion. So the second rule guiding electronic configuration is called Pauli's exclusion principle. And the third rule that we must take note of in writing electronic configuration is called Ohm's rule. Ohm's rule of maximum multiplicity. Now, not to waste our time, off-bow is talking about energy. Energy, which means that electrons should be filled to orbitals having lower energy before going to higher energy. These orbitals have series of different energy levels. For instance, you have to cross it in this format. You cross it in this format. You cross it in this format. Ladies and gentlemen, what this means is that you write for 1s before 2s, then 2s before 2p, from bottom to top. From bottom to top. 2s, the first line is 1s. The second line we have 2s. The third line we have 2p and 3s. But you write the bottom one before the upper one. And that is why it is said electrons are filled to orbitals having lower energy. This 2p is having lower energy with respect to 3s. That's off-bow principle. Pauli's exclusion principle. Pauli's exclusion principle is talking about the exclusive property of each electron. What that means is that electrons, no 2 electrons, can have the same 4 quantum numbers under electronic configuration. And Ohm's rule of maximum multiplicity tells us that electrons are filled singly into the orbitals before pairing occurs. Ladies and gentlemen, these are the 3 principles you may be asked. The 3 principles guiding electronic configuration. These are them, and I've given you the debrief of the definition. Now, how do we write the back to where we are coming from? How do we write the electronic configuration of the element that is having atomic number of 25? The first orbital that we are going to write is what? Is what? I want you to think about it with respect to the explanation.
1s2.
Good. 1s2. The next one with respect to the explanation is what?
2s2.
2s2. Somebody may want to write 3s2. That would definitely be wrong. Because I've told you that you fill electrons to orbitals that are having lower energy before higher energy. With respect to this, you see that 2p is lower than 3s. So we have 2p, 6, 3s, 2. Do we understand? Now, we are writing the electronic configuration for how many electrons? For 25 electrons. These figures, these powers, represent the number of the electrons. That means we are going to add the number of the electrons. 2 plus 2, 4, plus 6, 10, plus 2, 12. Remaining 13 electrons. After 3s2, what we have next is 3p6. 3p6. Then we have 4s2. Then we have 3d. Let's count again. We have 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 2, 20, out of a total of 25. It therefore means that we need 5 more electrons to write on top of this d orbital. We need a total number of what? 5 electrons to write on top of that orbital. Ladies and gentlemen, it therefore means, going back to the question, which says the element 25 has an electronic configuration ending with, if you look at the question, if you look at the electronic configuration, the last configuration is 3d5. And that is why this is the correct answer. And that is why this is what? The correct answer. Alright.
Continue.
Good. So this is the right answer. Now to cut the long story short. That's the answer. What about other questions that you may be asked under this topic? Ladies and gentlemen, you may be asked, what is how many unpaired electrons does this orbital have? For instance, s orbital is subdivided into no other orbital. P orbital is subdivided into 3 different orbitals, which are px, py, and pz. Are we on the same page? D orbital is subdivided into 5 different suborbitals, which are dxy, dyz, dxz, dx squared minus y squared, and dz squared. Alright? So the representation of the orbitals, d orbital, is subdivided into 5. It's subdivided into 5. And we have a total number of what? 5 electrons. According to Ohm's rule of maximum multiplicity, electrons are filled singly before pairing occurs. So we fill them singly first. 3, 4, 5. Out of 5 electrons, we just exhausted the 5 electrons. And we are on the same page. Assuming we have 6 electrons, we are going to pair the second one here. And it will be facing downward. It will be a clockwise order. So what that means is that how many electrons are unpaired in this shell? This is standing alone, standing alone, which means we have a total number of 5 electrons that are what? That are unpaired. Good. Now that is number 1. Number 2, this question is coming from the organic realm of chemistry. This question is coming from the organic realm of chemistry. And if you don't understand chemistry, organic chemistry to be precise, if you don't understand it properly, you may be found wanting. There's a video for you. I will give you the link to the video under the comment section, whereby you find where we have discussed organic chemistry in its totality. Organic chemistry in its totality. Now, look at this question properly. It's more or less a diagrammatic question. You have substance X. It may look confusing to some other person, but for chemists, this is one of the simplest. Alright? Look at this arrow. Look at where the arrow is pointing to. What this means is that substance X is reacting with steam. And they are passing through heated catalysts to give you carbon monoxide as one of the products and hydrogen as another product. After the diagram we have, the question says, which substance could be X and Y? Which substance could be X and Y? Ladies and gentlemen, let's interpret the question. Let's interpret the question. Substance X, like I've explained, X plus steam. The chemical formula for steam is what? H2O gas. Are we on the same page? The catalyst used, this is one type of reaction called catalytic reaction. We have catalytic reaction, we have reversible reaction where the arrow is going forward and backward. We have combination reaction where A plus B is combining together to give you a product. We have double combination, we have decomposition, we have double decomposition, we have redox reaction, and a host of others. This is also covered under another video. But in a nutshell, this presentation, our objective is mainly for post-UTME students. So these things that I'm saying should not be strange to you. X plus water gas gives carbon monoxide. Carbon monoxide is CO. And hydrogen gas. And hydrogen gas. Now the question says we should identify substance X. And later on in the day, it is discovered from this diagram, it is discovered that this hydrogen gives an unsaturated vegetable oil to give substance Y. So we are required to identify substance X and substance Y. But from the first equation that I've written, X reacting with steam, passing through heated catalyst to give you carbon monoxide and hydrogen. Do we understand? Meanwhile, the hydrogen is reacting with unsaturated vegetable oil to get substance Y. Alright? So in a nutshell, what this will be telling us is that mathematically, if I'm having A plus B to give C plus D, if I'm in need of A, I will just do what? I'll just make A the subject of the formula. In that case, that will be A is equal to C plus D minus B. Ditto to this reaction, I'm having X plus water to give me carbon monoxide and hydrogen. In a nutshell, if I'm in need of X, I'll just say my X is CO plus hydrogen to give what? To give a minus water vapor. Minus water vapor. Minus water vapor. Good. However, you can see that I can easily remove 2 hydrogen from this and 1 oxygen from this to get carbon left over. However, from the equation, if you look at the question, if you look at the options, none of the options has carbon as X. Had it been one of the options contain carbon, then we are good to go. Then it is either methane or ethane. If it is methane, it means we are going to need 4 carbon atoms. We are going to need 4 more hydrogens. Plus these 2 hydrogens, making a total of what? 6 hydrogens. Therefore, if we should put 3 here, that's a total of how many hydrogen? 6 hydrogen. And put 3 here, we are having 6 hydrogen, which means 6 hydrogen minus 2 hydrogen gives us 4 hydrogen. 1 oxygen minus another oxygen gives us no oxygen, and this carbon is left over. Alright, meaning we'll be left with what? We'll be left with carbon and 4 hydrogen. It means our X is CH4. Our X is CH4. After identifying our X, the next objective is to identify substance Y. However, from this, hydrogen and unsaturated vegetable oil is reacting together. One of the reactions of chemistry. When you are reacting hydrogen with unsaturated vegetable oil in the presence of nickel catalysts, that is no other reaction than hydrogenation of vegetable oil. Hydrogenation of vegetable oil is an addition reaction, moving from unsaturation to saturation. Now, hydrogenation of vegetable oil will lead to margarine. This is applied in industries that are producing butter, top bond, and the likes. Industries that are producing Bama butter, mayonnaise, and the likes. What they actually do is hydrogenation of vegetable oil, groundnut oil. And that is why if you put your butter, if you put it onto a frying pan and you fry it, it will later turn back to vegetable oil. It is vegetable oil that is being converted to butter. So if you are eating butter, you are actually eating a garnished vegetable oil. If you are putting butter inside your food, you are actually eating a garnished vegetable oil. Garnished vegetable oil that is garnished in the industry. Hydrogen plus vegetable oil is why you are having your butter. So in a nutshell, what that means is that we are having hydrogen plus vegetable oil in the presence of nickel catalyst to give you no other products than what? Than margarine. Some other times you may be asked, what is the catalyst used in hydrogenation of vegetable oil? It is nickel catalyst. What type of reaction is this? It is hydrogenation addition reaction. Hydrogenation addition reaction. Good. Okay. Right. So it means, look at the options. Which one of these is correct? Methane and margarine. Methane and margarine. With a limit in time and space. The next question: which equation represents the reaction that occurs when calcium nitrate is heated strongly? Calcium nitrate. Not to waste our time, whenever you are eating calcium nitrate, there should be something like this showing that it is undergoing heat. Whenever you are eating calcium nitrate, ladies and gentlemen, there are three products: calcium oxide, which is quicklime, nitrogen 4 oxide, and oxygen gas. So not to waste our time, even if you look at this option, it is wrong. There is nothing like this. Chemically, this is wrong. Chemically, this is wrong. So these two options are wrong. Do you understand? So note, this is very common in the questions. Do you understand? This is also called quicklime. I want you to note it. Quicklime. Quicklime. We have soda lime. We have slaked lime, and so on. And so this is what? This is quicklime. This is quicklime. Good. And we have lime water. We have CaOH2, and we have soda lime, NaOH. All right. So the next question, which means this is the answer. The next question says, calculate the pKa for ethanoic acid with hydrogen ions concentration of this. Let's quickly solve this question. We have to quickly solve this question so that we don't take excessive, indeliberate, and irreconcilable time. Alright? pKa is under acid, base, and salt actually. Or we can find it under chemical equilibrium. Ladies and gentlemen, pKa is equal to, there's a formula that says pKa is equal to minus log Ka. Minus log Ka. There's a relative formula that says pH is equal to minus log concentration of hydrogen. These are the formulas that you require to solve questions under these topics. Under this topic. Then we have POH minus log OH minus. This square bracket in chemistry means concentration. Means concentration. It means what? It means concentration. At the same time, there is a formula that says Ka is equal to concentration of products all over concentration of reactants. There is one last formula that says OH minus times H plus is equal to 1 times 10 to the power minus 14. Permit me to write the last formula, POH equals to 14. Alright? K is product over reactants, concentration of product over reactants. Look at this question. Calculate the pK for ethanoic acid with hydrogen ion concentration of ethanoic acid is splitting CH3, COOH is dissociating to what? Is dissociating to what? CH3, COO minus and hydrogen ion. And hydrogen ion. Alright? So the Ka is the concentration of the ethanoids. This is called ethanoids. And the concentration of the hydrogen ion all over with respect to this equation. With respect to this equation, all over the concentration of the reactants. concentration of the reactant. It therefore means that we need the concentration of this, and this. However, to God be the glory, we are giving the concentration of the hydrogen ions, which means we've gotten the concentration of this. Believe me that concentration of the product will always be the same at initial step. Let's say CH3, COOH, the concentration is X, alright, which we don't know. Let's assume we don't know it. The concentration of the reactant CH3, COO minus, and hydrogen ion is 0 before reaction. At time T, at a particular time, we have discovered that the concentration of the hydrogen ion is what? 1.75 times 10 raised to the power minus 5. Ladies and gentlemen, simply because this is equilibrium reaction, it therefore means these other reactants will have similar concentration with the hydrogen ion. It means this will be 1.75 times 10 raised to the power minus 5, and this will be X minus 1.75 times 10 raised to the power minus 5. This is no thanks to the fact that since you got the concentration of this, do you understand? And you know this is the reactant that is having concentration. Do you understand? So you remove the concentration of the product, one of the products, from that X. By the virtue of the fact that it is a small number, it can be rationalized and equated to the 1.75 times 10 raised to the power minus 5. So we now say Ka is equal to 1.75. Going back to this equation, do you understand? Times 10 raised to the power minus 5 times 1.75 times 10 raised to the power minus 5 all over